They are Mr. Dong Chen from Cundall Hong Kong Limited, and Mr. Desmond Lee, also from the same company. And Dong is a structural engineer with over 20 years of professional experiences internationally, including Europe, UK, US, Middle East, South America, and Asia. And Desmond has an educational background in renewable energy engineering and sustainable architectural design. He is a qualified BIM professional and well AP with strong solid management skills and has managed several BIM Plus projects with a successful delivery. So Mr. Chen and Mr. Lee, over to you, please.
Thank you, Chairman. Thank you, Secretary of Environment, and thank you, distinguished speakers. And thank you, ICE, for having us here to share our experience with all of you about how we are using CIC carbon assessment tool and also the advanced structural optimization parametric modeling design to deliver low carbon design to the project. I'm sure most of us has very good knowledge or background about what is the embodied carbon in the building industry, but I would like to take a few minutes here to share with all of you about align the definition of embodied carbon among us. Embodied carbon or upfront carbons mean the carbon emission related to the manufacturing, transportation, and installation of construction material. Those carbon emission before the handover stage to the project owner or the operator. So by definition, we can split the embodied carbon of a building through the building lifetime in different stages. What I want to focus today is about the A1 to A5, which includes the embodied carbon related to the material harvesting, transportation to manufacture, and the emission in the manufacturing process. From the manufacturing process and the transportation from the manufacturer to the sites, and also the site impact. Back in decades, throughout the whole building life, we can see that the portion of carbon emission from the operational stage would be larger than the carbon emission from the embodied carbon. But with the talented people in the industry applying, say, passive design in the building design, architectural design, and also applying high efficient equipment in the building installation, building surfaces, it helps dramatically reduce the operational carbon emitted to the atmosphere throughout the building lifetime. But at the same time, we haven't really looked into the embodied carbon part. So the portion of from embodied carbon for a building has increased, although the whole carbon emission of the building has reduced, but the portion has increased for the embodied carbon. So based on the research in 2019, there are 28% of global carbon emission were from the building operational directly, and 11% of that from upfront carbon or embodied carbon directly to the global atmosphere. This is not small portion. It's a quite sufficient. It's a quite a large portion that we have to tackle. And by excluding, when we excluding the operational carbon and operational energy consumption or operational water consumption, by looking at only the embodied carbon, the A1 to A3, which the material manufacturing process, contribute about 48% of the embodied carbon, and also 45% of the embodied carbon were from maintenance and replacement. The A1 to A3 and the embodied carbon for B1 to B5 are somehow directly related because of the material inherent carbon emission due to the manufacturing process. So what I want to present here based on the LITI research for London is that embodied carbon is something that we have to look at this chart help us to review it in another point of view or perspective. So based on this Advancing Net Zero published by the World Green Building Council, launched a roadmap or targets that they would like to reduce 40% of the reduction in embodied carbon for new buildings and new infrastructure in 2030, and achieving net zero for whole life carbon for new buildings and infrastructure by 2050. So this is the roadmap they set for the industry. So CIC back in 2017 and 18, they found that they are missing link for the Hong Kong building industry to carry out audits or a carbon audit for their projects. Therefore, CIC appointed Cundall to prepare the carbon assessment tool, and which launched back in 2019. This is a free tool online platform for everyone in the industry to look at or to reference to carry out a carbon emission audit for the project by applying a localized carbon factor, especially for the transportation carbon factor and also the site impact carbon factor. It's also connected to the CIC carbon assessment, the GBC database. I'll go through about this later on. This is the web page looks like, and that's the URL, so everyone can go and have a look about it. Since back in last year, there are over 800 registered users, over 600 registered projects, and over 800 building material can be used in the tool. And these numbers keep going up, including the material used. This tool is applicable to design project or construction stage in the project. So in the design stage, we as a consultant, we always recommend the client and the project team to use low carbon concrete in their and for the projects. CIC Green Product Certification scheme webpage, it's where a good website for us to do some research on and see if there are any low carbon material we can apply to the project. In general, electrical arc furnace rebar has 60% less carbon emission than blast furnace steel. So this is also what we would always recommend to the client and project team to have a look and see if there are any opportunities we can use EF rebar instead of BOF rebar in the projects. PFA or GGBS is also another thing that we would recommend to use to replace cement in the concrete mix and help to reduce the embodied carbon for the project. And by advanced structural optimization design, high strength concrete is something that we would like to also propose to the clients to potentially reduce the use of rebar, and as well as reducing the overall carbon emission as well. Don will cover it a bit more on this part later on. And by the CIC carbon assessment tool, we can draw two different designs together and the same page for comparison, help the project team and the clients to review the different designs in terms of the carbon impact for the project and help them to make decision in terms of the carbon emission. And in construction stage, these are the items that they would be account in the CIC carbon assessment tool, which affecting the site impacts carbon emission. Construction stage, we can also draw the design value together at the same page to for comparison to see the design value and the construction actual value and see if there are any difference, and to help the project team, the main contractor and the clients to review the current performance and also help them to potentially reduce their embodied carbon in the future projects. Benchmarking function is also available since December last year to help the project team to review the project performance compared with similar project type and see if there any potential to reduce the carbon emissions as well. And other than the embodied carbon, low carbon material usage percentage, clean energy usage percentage, and also waste recycling percentage also present in the webpage as a KPI for the projects to review the performance, the overall environmental performance. So how are we using advancing structural design to help to deliver low carbon material? I will pass it to Dawn to have some presentation to share our experience with you guys. Thank you.
Thanks, Desmond. Can you go to the next page, please? Yes, so as mentioned, I'm a structural engineer practicing structural design my whole career. So this is carbon related discussion never been too new for our industry, but it's time to people pay a bit more attention because many of the high level targets being set up. So one of the issue I realized in my career is most time clients would only pay attention for the operational carbon during the when the building finished, because the design team tend to be only look at the cost, which is sensible, and because naturally when you reduce the material usage, reduce the cost and reduce the carbon, this logic. But it's not just that, because sometimes your early design decision, your design strategy, for example, for structurally low impact structural system typology will also have impact to the embodied carbon. And often as a designer, we overlooked this design criteria and too much focus on the efficiency and also the cost. And this diagram my colleague also showed earlier here. This been presented in a way to show in which phase and the embodied carbon contributed how much. As you can see, for front phase, generally design phase, you will contribute almost 50% of the whole life cycle embodied carbon. It's very significant. Again, this is because this will vary a little bit depending on type of the product, type of the building. For example, if it's a data center project, you will have more embodied carbon during the operational phase, probably have a slightly less amount during the front phase. But again, as a designer, we shouldn't ignore the opportunity to influence the design to help the overall project to achieve the a new carbon neutral or low carbon design in a shorter time frame. Next page, please. So when we say, Desmond also presented briefly about, the difference between the embodied carbon and operational carbon. And this is just a simple diagram to show, depend on typology of the building, the project, and the distribution of the embodied carbon and also the operational carbon. As you can see, the orange part generally means we have a huge amount of the carbon which is coming together with the structure solution or design solution we choose at first place. Next page, please. So that means why are we doing this as structural engineer? So because a structural engineer, as the nature of our job, we look at the design from the beginning, trying to look at structural performance, cost, material quantities, and the program impact, buildability. Embodied carbon is naturally just another important indicator during design optimization. So we then, on the right-hand side, you can see if we can look at this indicator during the planning and design phase, we would have a huge contribution to the overall life cycle carbon of the project. So it's no wonder we should be doing that. Next one, please. So when we're doing the design, because the nature of the project, most often the designer or the structural engineer, we work with architects, we tend to have the involvement during the design phase. So when the building is handed over, apparently there will be separate operational team, and the designer will be, will not have more involvement. But we want to use the opportunity to say, even we only can be involved in the design phase, which is limit upfront embodied carbon, we will have a huge influence to the overall performance of the building from the carbon perspective. So we have many tools to do that. You know, we have a different computer program, you know, BIM software, and we can have direct access of the structural material information, and we normally provide to the cost consultant for the cost study, and the embodied carbon assessment tool, which is also Desmond mentioned, built in local carbon factors, which can be brought in as part of the material property, which is we can use that for demonstrate the saving or the performance along with other indicators such as the cost and the efficiency. And we have many useful structure design tool can be further developed to implement that function. This is where we were trying to use some of our real project to using something called Parametric tool, which is literally a visual program. And then we plug in the localized carbon factor and trying to test the structural design from all these perspectives, including carbon. Next page, please. So how we do this? And normally we rationalize the structure, we make it more efficient. We trying to reduce the material usage, and we they improve the structural utilization, and some of the structural components should be considered multiple purpose. Then you can save the material as well. And then design for the reuse and material minimize the wastage, and also design for demolition towards life. All this apparently will echo the phases as we presented earlier. In each phase, it will have a influence or impact, small or big. Then we also can specify the low carbon materials, some so-called green concrete, recycled steel, reinforcement, or even like a timber or some more low carbon material whenever it's possible in Hong Kong or in elsewhere. And next page, please. So this is probably a more interesting part, you know, how we really use that in the real life, in the real project. But before that, I want to talk about a little bit background about the approach. So the part we are looking at, we call front face A1 to A3, generally called cradle to gate. So when the material to be prepared into the actual construction material, then used for construction. So, and being selected or adopted by the design team in the design. So this cradle to gate. Then this design documentation will be provided to the contractor to the site. So our focus will be focused on the cradle to gate phase. So there are two separate approaches, you know, it depends on the client brief. And sometimes option one, we only focus on the embodied carbon counting and why the structural design is carried about other parties. We just help the client to them to evaluate the carbon impact for each option. So this is a more straightforward and let's say simpler version. Then option two is a more holistic version. So because we are also structural engineer, structural designer, as I mentioned earlier, I think is a natural sense just to integrate the carbon indicator into the design iteration. So we have a more holistic approach. You know, we'll look at the structural stability, performance, deflection, material strength utilization, as well as carbon reduction. So of each option, we look at it during design iteration phase. Next page, please. So just click again. So this is something we've been trying at Cundall in the global business. So as I mentioned, you know, in Hong Kong now we have a CIC localized carbon factors. In UK, we use IC database, and we also have those integrated structural material in our BIM platform. So we using as part of BIM workflow in Dynamo. So in our Revit, you know, software, we open it, we look at we build up the structure model from the design team. In the end, we also can calculate the carbon factor from that process. But this is more towards the end when you have the option studied already, is simply doing the counting. So that's sort of a one-way process. So in here, after we get the CIC database together with our sustainability team, we think it's much better to include that tool as part of a design parameter. So when we look at design option, we also can instantly see the impact of carbon. So we don't have to wait until the documentation phase. We can do that at a very early stage, even like a conceptual phase. So we can quickly examine the proposals from the architects, from the client. Then we can give them a feedback and help the decision-making process. So we have developed our own parametric tool using the common Grasshopper platform. Next page, I can show some of the image. So basically, we taking the data from CIC, then trying to using this process quickly read each design option, then give the comparison of each option in term the material quantity, also the carbon implication. So the data we collect from the design phase more focus on the primary structural elements, because these are the elements affect the structural behavior and also contribute a majority of the embodied carbon. We have some study also Desmond also showed what's the percentage of non-structural material, for example, like a facade, MEP equipment, even the furnitures or interior design elements, how much percentage that contributes to embodied carbon, let's say 20 to 30%, but majority are coming from primary structures like superstructure, substructure, or foundation. Next page, please. So I don't know how many listeners understand the structural design optimization, but imagine in the 1,000 years, the structural engineers is not a rocket science. So we take the geometry or picture or vision from an architect or designer, and we start to help them to look at the different typology of the structure. We do some optimization, and we look at topology. We look at shape. Then we give them the member size, for example, beam size, column size, then slab thickness. Then eventually this number will be converted, to the tonnage of the steel volume. Then this number will be able to adopted by our QS to look at the actual cost. So this is the conventional approach. You can still do that. Nothing wrong with it. There was many design spreadsheets being developed by different institutions do that, but that's generally a manual process. So next page, please. So we're trying to do something more, slightly more clever. I wouldn't say it's most clever, but it's something we're trying to do. We now handling much more complicated, more larger scale project. So often the client want to a quick feedback. If each option they want to evaluate, they want to make a decision. How we can quickly pick up the challenge and take the challenge as a professional in the modern days. We start to look at more and more using computation design or AI process to help us to develop structures to get most efficient system. But at the same time, we put it into the carbon counting elements to quickly give the result for each options, as I mentioned earlier. Then eventually, with the option like step 3, when everything is tick all the boxes, come up with most balanced design from the structural performance and the carbon perspective, then we'll push everything into the documentation part. Next page, please. So this is the process which we're developing internal now. So we get the design finished in the Rhino, in the Grasshopper, then push it to the for example like a Revit, and we documentation also have the embodied carbon counting result come out, and then the middle part is showing the process how we instantly push the geometry or structural geometry into Revit. So we design, and when design is done, the documentation is done. It's almost there in parallel. So it's a very efficient process. Then the right-hand side of the picture is showing the not the same project, it's example. When push out, we push a number to show each option have different carbon implication. So the graphic actually is a UK score system from Astra E to show the embodied carbon performance of each option. So basically, you can have a quicker overview of the option you have examined. And also you have the documentation is ready for going to the next design phase or construction phase. Next page, please. So we want to show some more real projects, just to give you guys some taste. I know the time limit, I can't go into the detail, but just give you overview. So I'm happy to explain more after this kind of this event. So this is a project we're doing in Japan. It's one of our project Growthsna, their first carbon neutral ready project in Japan. So in this case, we set up a model. So this model all done in the Grasshopper is a visual programming platform. Then we build up the function module for block. You can see this pattern. Some patterns are used for calculating the structural, reading the geometry. Some are used for analyze the structural performance. And the purple part, for example, for exporting the structural result, the study results. The green patch, the green part, is actually we build additional function for reading the carbon for each phase. So when the look at the option, for example, we look at the 5 different options, A, B, C, D, E, then each option will be quickly compared by looking at their structural performance, also which is reflected as a material tonnage, and then also the embodied carbon factor. So then we do that analysis, and then export, push the result out. On the bottom left, there is a summary, a simple summary to show each option. They have carbon performance, also material efficiency. So this is an example.
Just a gentle reminder of the time.
Yeah, sorry. Yeah, the quick one. Next one is we are doing recently with Ronaldo in Hong Kong. We win this treehouse for best future design. Then this one would adopt a similar approach to optimize structure to the way we greatly reduce embodied carbon in the front phase to help the project to reach carbon neutral in the short time frame. Next page, please. And similarly, we do another project in Hong Kong Science Park. We look at each parameter, design parameter, to demonstrate to the client by doing each step how we can reduce, or sometimes doesn't reduce, actually increase, but we test, we examine, we don't miss the opportunity at the early phase. Next phase, please. So this project we're doing in it's also a project done by my team. We also look at the embodied carbon factor, but embodied carbon for study for the bridge project is relatively new. Australia just published a new publication, and there is a supplementary information about how to calculate the bridge carbon. But there is, because the bridge has a slightly different implication because it has more front work and also earthwork. Also have a longer use life, maintenance life, so have a more implication in terms of the distribution of carbon will be slightly different, but the principle will be very similar. We adopt a similar approach and to do this project. I think that's the last one. Yeah, that's all. Thank you so much.
It's an excellent presentation and sharing. There's a lot of details and elaboration. I really appreciate. Probably we'll only have time for a very quick question. I read the question for both speakers, please. You talked about the structural optimization in order to reduce embodied carbon. Well, often engineered low carbon structural design solutions are subject to the onerous scrutiny by the building control authorities.
Yep.
And sometimes compromise to conventional options. So how do you think the low carbon structure design solutions could be promoted in Hong Kong?
Yeah, so the whole idea, we want to promote integrated processes when we do the structural design, while they're satisfying all the structural principle statutory requirement. At the same time, we don't miss the opportunity of reducing carbon. So we are not just tell the BD officer, okay, we're going to use a different type of material. No, we'll look at a different structure system, the loader path. So holistically, it will still comply with the local code. So with a practical solution for reduced carbon, but we're also trying to give the authority inspiration how potentially, because the code changing, the regulation change, I don't believe Hong Kong will stay like this for 10 years time. The rule will be changed because the technology and the material are very well developed. So let's see potentially how this project can be achieved. So one of the projects we're doing is Hong Kong Science Park. We give them the practical solution, immediately can be approved by BD. We give them more stretched option to inspire the client and authority. But that's what we're trying to do. Yeah.
That's very good. Desmond, would you supplement?
Yeah. Other than the design, which Don covered, there's also opportunity to select low carbon material to for the building, which will not affect the BD approval, but also reduce the embodied carbon for the project significantly. So this is something that we will not affect the design, but also we recommend the clients to consider it in the design. Yeah, thank you.
Okay, that's excellent. Once again, thank you, Mr. Lee and Mr. Chen, for your expert sharing.
Thank you.
Thank you.